before the first letter was ever carved into stone, before ink preserved ideas upon paper, before stories filled libraries, before names were spoken across villages, before language itself had fully emerged, humanity still had something to say. Hundreds of thousands of years ago, our ancestors lived in a world without books, without writing, and without history as we know it. There were no alphabets, no conversations recorded for future generations, no poems, no songs written down, no voices preserved across time. Yet every day they hunted together. They protected their children. They warned one another of danger. They shared food. They mourned the dead. They celebrated survival. Somehow, they communicated. But how? What did the very first humans sound like? Did they speak in words we would recognize? Did they rely mostly on gestures? Did they point toward danger instead of describing it? Did they sing before they spoke? Did they laugh before they learned language? Could a mother comfort her child without words? Could hunters organize a dangerous hunt using only movement and simple sounds? And perhaps one of the most fascinating questions of all, could our closest ancient relatives, the Neanderthals, speak as we do? Or did their voices sound entirely different from our own? These questions have fascinated scientists for generations, because unlike stone tools, language leaves almost no trace behind. A spear may survive for hundreds of thousands of years. A cave painting can remain hidden for millennia. A human skeleton may rest beneath the earth until archaeologists uncover it. But a spoken word disappears almost the moment it is heard. No recording exists of humanity's first conversation. No ancient voice echoes through time. Whatever those earliest people said, the wind carried it away forever. That is why the origin of language remains one of the greatest mysteries in human history. Scientists have searched for answers using many different fields of research. Archaeologists study the lives of early humans through the objects they left behind. Linguists examine how languages change and evolve over thousands of years. Geneticists investigate the DNA that may have helped make speech possible. Anthropologists compare cultures from around the world in search of patterns that might reach deep into humanity's past. Neuroscientists explore the remarkable regions of the brain responsible for language, memory, and communication. Each discipline contributes another small piece to an enormous puzzle. Yet no single discovery has revealed the complete picture. Some evidence is remarkably strong. Other ideas remain informed scientific theories. And many questions continue to inspire lively debate among researchers today. That uncertainty is not a weakness. It is simply the nature of studying a past so ancient that almost every spoken sound has vanished forever. Before we continue, it is important to make one thing clear. This documentary explores the scientific study of language origins through archaeology, linguistics, genetics, anthropology, and evolutionary biology. It does not claim to know humanity's first word or the exact moment language began. Many of the ideas discussed are based on the best available evidence, while others remain well-supported hypotheses rather than established facts. Wherever uncertainty exists, we will distinguish evidence from interpretation. Tonight, we journey back not thousands, but hundreds of thousands of years, to a time before alphabets, before books, before writing, before recorded history, to search for something no archaeologist has ever excavated, the first human voice. Long before history was written, humanity may already have been speaking. Long before the first stories were spoken. Long before language carried ideas across generations. Long before names identified families, places, or people. Humanity was already communicating. Nearly 300,000 years ago, the world looked vastly different from the one we know today. Modern cities did not exist. There were no roads stretching across continents. No farms. No villages. No kingdoms. Only wild landscapes where survival depended entirely upon the natural world. Across the plains of Africa, small groups of early Homo sapiens wandered in search of food and water. They followed migrating animals across open grasslands. They gathered edible plants, fruits, roots, and nuts. They avoided dangerous predators that often hunted the very same territory. Every sunrise brought uncertainty. Every sunset carried new dangers. Life was simple, but never easy. These early humans lived as hunter-gatherers. Unlike later civilizations, they owned very few possessions. Everything they carried had to be useful. Stone tools, wooden spears, simple containers. Animal hides for warmth. Their greatest resource was not technology, but each other. No individual could survive alone for very long. Children depended upon adults. Hunters relied upon teamwork. The elderly preserved valuable knowledge gathered through decades of experience. Success belonged not to the strongest individual, but to the most cooperative group. And cooperation required communication. But communication did not necessarily require language. Imagine a hunting party silently moving through tall grass. A single raised hand tells everyone to stop. A finger points toward movement hidden among the bushes. A quick glance warns of approaching danger. No words are spoken, yet everyone understands. Long before complete language existed, gestures may already have carried powerful meaning. A raised arm, an open hand, a nod of the head, a sudden movement of the eyes. Each action could communicate information essential for survival. Facial expressions may have been equally important. A widened stare could signal fear. A smile might reassure frightened children. A tense jaw could warn others to remain alert. Expressions often communicate emotions far more quickly than words ever could. Even today, people across cultures recognize many facial expressions almost instantly. Happiness, fear, anger, sadness, surprise. These emotional signals appear deeply rooted within the human brain. Eye contact may also have played a remarkable role. Looking directly at another person can communicate attention, trust, warning, or reassurance without a single spoken sound. Among close family members or experienced hunting partners, a brief exchange of glances may have conveyed enough information to coordinate complex actions. Body language completed this silent system of communication. The position of the shoulders, the direction of movement, the speed of a person's walk. Even posture itself can reveal confidence, caution, exhaustion, or excitement. Together, gestures, expressions, eye contact, and body movement created a rich form of communication long before spoken language reached its modern complexity. But humans are not the only creatures that communicate. Across the animal kingdom, communication appears everywhere. Chimpanzees use dozens of different vocal calls. They point toward objects. They embrace one another. They display facial expressions strikingly similar to our own. Researchers have observed chimpanzees warning members of their group about predators, requesting food, comforting distressed companions, and coordinating social interactions through sounds, gestures, and touch. Wolves communicate in different ways. Their haunting howls can travel across vast distances. Body posture establishes social hierarchy. Ear position, tail movement, and facial expressions reveal intention before conflict begins. A single glance may prevent an unnecessary fight. Birds offer another extraordinary example. Many species produce complex songs. Some attract mates. Others defend territory. Certain birds even possess different alarm calls depending on the type of predator approaching. Some sounds warn of danger from the sky. Others signal threats on the ground. These communication systems are remarkably sophisticated, yet they differ from human language in one fundamental way. Human language allows us to discuss things that are not physically present. We can describe yesterday's hunt, plan tomorrow's journey, imagine places we have never seen, invent stories that never happened, ask questions about the future, wonder about life after death, explain ideas to children who were not present when events occurred. Language allows thoughts themselves to become shared experiences. Animal communication, although often highly intelligent, usually focuses upon immediate situations. Food, danger, territory, mating, social relationships. Human language expands far beyond the present moment. It allows memory, imagination, planning, and abstract thought to travel from one mind into another. Exactly when this remarkable ability emerged remains one of the greatest unanswered questions in science. Perhaps it appeared gradually over tens of thousands of years. Perhaps gestures slowly combined with simple vocal sounds. Perhaps each generation added a little more complexity than the one before. There may never have been a single moment when language suddenly appeared. Instead, it may have evolved quietly, almost unnoticed, as human minds became increasingly capable of sharing ideas rather than simply reacting to the world around them. The archaeological record cannot preserve those earliest conversations. No spoken sentence survives. No forgotten voice echoes across time. Yet every successful hunt, every protected child, every shared meal, suggests that communication was already becoming more sophisticated. The path toward language had almost certainly begun. Whether those first sounds resembled anything we would recognize today, no one can say. But one truth seems increasingly clear. Communication already existed, but language may still have been waiting to be born. Long before the first sentence was ever spoken. Long before stories traveled from one generation to the next. Long before humanity developed the languages we know today, something extraordinary was already changing. Not in the hands, not in the mouth, but inside the human brain. The ability to speak does not begin with the voice alone. It begins with the remarkable organ that gives meaning to every sound we produce. For millions of years, our ancestors evolved alongside a changing world. Different human species appeared. Some disappeared forever. Others survived long enough to leave traces beneath the earth. Among them, Homo sapiens gradually developed one of the most complex brains ever known. By roughly 300,000 years ago, anatomically modern humans had already appeared in Africa. Their brains were similar in size to our own. At first glance, it might seem reasonable to assume that a larger brain automatically meant better language. But modern science tells a more complicated story. Brain size alone does not determine intelligence, nor does it guarantee language. Some extinct human relatives possess brains as large as, or even slightly larger than, those of modern humans. Yet we still cannot say with certainty that they communicated in the same way we do today. The organization of the brain may have mattered far more than its overall size. Within the modern human brain are regions especially important for language. One of the best known is called Broca's area. Located in the frontal lobe, this region plays a major role in producing speech. It helps organize words into meaningful sequences and coordinates the complex movements required for speaking. Damage to this region today can make speech slow and difficult, even when a person still understands language. Another remarkable region is known as Wernicke's area. Located farther back in the brain, it plays an important role in understanding spoken language. People with injuries affecting this area may continue speaking fluently, yet their words no longer carry clear meaning. Together, these specialized regions illustrate something remarkable. Language is not controlled by a single location. It depends upon an intricate network connecting memory, hearing, movement, attention, and thought. Every sentence spoken today represents countless neurons working together with astonishing precision. But when did these remarkable systems first emerge? That question remains one of the greatest challenges in evolutionary science. Brains rarely survive in the archaeological record. Unlike bones, they disappear long before fossils can form. So how can scientists study the brains of ancient humans? One important clue comes from fossils themselves. Although brain tissue is lost, the inside of the skull sometimes preserves its overall shape. Researchers create detailed models known as endocasts by studying the internal surface of fossil skulls. These endocasts cannot reveal individual thoughts or exact brain functions. However, they can provide valuable information about brain size, overall shape, and the relative development of certain regions. By comparing fossil endocasts from different human ancestors, scientists have discovered that the human brain changed gradually over millions of years. Its shape became increasingly rounded. Certain regions expanded. Connections between different parts of the brain may also have become more efficient. These changes suggest an increasing capacity for complex thinking. Yet fossils alone cannot explain language. Modern neuroscience offers another important source of evidence. By observing living people using advanced brain imaging technologies, scientists can watch different parts of the brain become active during speaking, listening, reading, remembering, and problem-solving. These studies reveal that language depends upon far more than vocabulary. It requires memory. Consider a simple conversation. To understand even one sentence, the brain must remember the words spoken only moments earlier. It must recognize grammar, interpret meaning, connect new information with previous knowledge, predict what may come next, all within fractions of a second. Without memory, language quickly falls apart. Memory also allows knowledge to pass across generations. Parents teach children. Elders preserve experience. Hunters explain successful strategies. Communities remember dangerous places and reliable water sources. Over thousands of years, shared memories become shared culture. Another remarkable ability closely connected to language is symbolic thinking. Symbols allow one object to represent something beyond itself. A sound may represent an animal. A gesture may represent danger. A name may represent an individual. Later, written symbols would represent spoken words. This ability to think symbolically transformed human cognition. Instead of responding only to what was immediately visible, people could imagine things that were absent. A future hunt, a distant river, an ancestor who had died, or an idea that existed only inside the mind. Planning depended upon this same capacity. Imagine organizing a hunt several days before it begins. The group must remember past experiences, predict animal movements, assign different responsibilities, prepare tools, coordinate timing. Such planning becomes vastly easier when complex communication is possible. As human communities slowly grew larger, communication became even more important. A family of 5 can rely heavily upon gestures. A community of 30, or 50, or 100 people requires far more detailed ways of sharing information. Larger groups needed stronger cooperation. Food had to be distributed fairly. Children required protection. Conflicts needed resolution. Knowledge had to spread efficiently throughout the community. Language offered extraordinary advantages. Ideas could travel faster. Mistakes could be avoided. Plans became more sophisticated. Communities became stronger. Some scientists believe these growing social demands helped drive the evolution of increasingly complex communication. Others argue that language evolved alongside many different changes occurring at the same time. The truth is likely more complicated than any single explanation. This is why researchers continue studying fossils, endocasts, genetics, archaeology, psychology, and neuroscience together. Each discipline contributes another piece of the puzzle. Yet one important lesson remains. A larger brain does not automatically create language. Brain size alone cannot explain humanity's extraordinary ability to speak. Instead, language appears to have emerged from the interaction of many remarkable developments. Memory, symbolic thinking, planning, social cooperation, specialized brain regions, and millions of years of gradual evolution. Perhaps none of these changes alone created language, but together, they transformed the human mind into something capable of sharing ideas unlike any other species on Earth. And perhaps, the greatest change was not the voice, but the mind behind it. Long before written language, long before the first civilizations filled the Earth, long before alphabets, books, and recorded history, humanity was not alone. For thousands of years, another human species walked beside our ancestors. They hunted across frozen valleys. They built fires. They crafted stone tools with remarkable skill. They cared for injured members of their communities. They buried some of their dead. And perhaps, they looked toward the same stars that we do today. These were the Neanderthals. For much of modern history, Neanderthals were misunderstood. Early discoveries portrayed them as slow, primitive, and intellectually limited. They were often imagined as little more than cave-dwelling brutes. But over the past several decades, archaeology has painted a very different picture. Today, scientists recognize Neanderthals as highly intelligent human relatives who survived across Europe and Western Asia for hundreds of thousands of years. They adapted to harsh Ice Age climates. They hunted enormous animals such as mammoths, bison, and woolly rhinoceroses. They created sophisticated stone tools. They controlled fire. They cared for injured companions who could not survive alone. Some evidence even suggests symbolic behavior. The more researchers learned, the more one remarkable question emerged. Could Neanderthals speak? It is one of the most fascinating mysteries in human evolution. Unfortunately, language rarely leaves fossils behind. Words disappear the moment they are spoken. Voices vanish into the air. Only bones remain. So scientists have searched for indirect clues. One of the most important discoveries comes from genetics. Within modern humans exists a gene known as FOXP2. This gene plays an important role in the development of speech and language. People born with rare mutations affecting FOXP2 often experience significant difficulties producing and understanding language. Because of this, researchers became interested in whether Neanderthals possessed the same gene. When ancient Neanderthal DNA was successfully extracted and analyzed, scientists made a remarkable discovery. Neanderthals carried a version of the FOXP2 gene that appears extremely similar to that found in modern humans. At first, this generated enormous excitement. Some researchers wondered whether this finally proved that Neanderthals possessed language. But science is rarely that simple. FOXP2 is only one small part of an enormously complex system. Language depends upon hundreds, perhaps thousands, of interacting genes along with brain development, anatomy, learning, memory, and social experience. Possessing FOXP2 alone cannot prove the existence of language. It simply tells us that one important biological ingredient was already present. Another remarkable clue comes from a tiny bone hidden deep within the throat. It is called the hyoid bone. Unlike most bones in the human skeleton, the hyoid does not connect directly to any other bone. Instead, it is suspended by muscles and ligaments. Although small, it plays a crucial role in supporting the tongue and coordinating many of the movements involved in speaking and swallowing. In 1989, archaeologists excavating Kebara cave in present-day Israel uncovered one of the most complete Neanderthal skeletons ever discovered. Among its preserved remains was an exceptionally well-preserved hyoid bone. Researchers compared it carefully with modern human hyoid bones. The similarities were striking. The Kebara hyoid appeared remarkably human-like. Computer simulations conducted years later suggested that it could have functioned much like our own. This discovery generated excitement. Perhaps Neanderthals possessed the physical anatomy necessary for speech. Yet another question remained. Even if the hyoid bone resembled ours, what about the rest of the vocal tract? The vocal tract includes the tongue, the throat, the larynx, the mouth, and the nasal passages. Together, these structures shape every sound we produce. Some early researchers argued that Neanderthals may have possessed a differently shaped vocal tract, limiting the range of sounds they could pronounce. Others disagreed, suggesting that newer anatomical reconstructions indicate far greater speech potential than once believed. The debate continues today. Scientists also study hearing. Language depends not only upon producing sounds, but also upon hearing them clearly. Recent studies examining the anatomy of Neanderthal ears suggest they were particularly sensitive to frequencies important for human speech. This does not prove they spoke, but it does indicate that their hearing was well suited for complex vocal communication. Another intriguing piece of the puzzle comes from the Denisovans. Unlike Neanderthals, Denisovans remain one of the least understood human relatives ever discovered. Most of what we know comes from only a handful of fossils and ancient DNA recovered from Siberia and parts of Asia. Remarkably, genetic evidence shows that Denisovans were closely related to Neanderthals. They also shared important genetic traits connected to speech, including versions of the FOXP2 gene. Yet because fossil evidence remains extremely limited, scientists know far less about how Denisovans may have communicated. The mystery remains even deeper. When all these discoveries are considered together, an intriguing picture begins to emerge. Neanderthals possessed sophisticated tools. They cared for one another. They survived in demanding environments. They carried a human-like FOXP2 gene. They possessed a remarkably similar hyoid bone. Their hearing appears well adapted for speech. None of these discoveries alone proves language, but together, they suggest that Neanderthals were far more capable than once imagined. Even so, one enormous question remains unanswered. If Neanderthals spoke, what kind of language did they use? Some scientists believe they may have possessed language almost as complex as our own. Others argue they probably communicated using a more limited system, perhaps containing many words but lacking the rich grammar of modern languages. Still others suggest Neanderthal language may have been fundamentally different from ours. Not better, not worse, simply different. A communication system shaped by hundreds of thousands of years of separate evolution. At present, no evidence can distinguish confidently between these possibilities. This uncertainty is one of science's greatest strengths. Researchers continue comparing fossil anatomy, sequencing ancient DNA, modeling prehistoric vocal tracts, studying brain evolution, and re-examining archaeological discoveries using technologies unimaginable only a generation ago. Each discovery brings us closer. Yet complete certainty remains elusive. Perhaps one day, new evidence will reveal how Neanderthals truly communicated. Or perhaps their voices have been lost forever. The conversations they shared around Ice Age fires, the stories they may have told, the names they may have given their children, the warnings whispered during dangerous hunts. All disappeared tens of thousands of years ago. No recording survives. No written words remain. Only silence. And perhaps, the silence of Neanderthals may never be completely broken. Long before the first language echoed across the earth, long before words carried stories from one generation to the next, long before names, songs, and conversations filled the air, the human voice was already alive. Not with language, but with sound. Every newborn enters the world with a cry. Long before a child learns its first word, it already communicates. Hunger, fear, discomfort, the need for comfort. Without vocabulary, without grammar, without explanation, a single cry can change the behavior of everyone nearby. This simple truth has led some scientists to ask an extraordinary question. If modern babies communicate before they speak, could humanity itself have done the same? Perhaps language did not begin with words at all. Perhaps it began with sounds carrying emotion and intention. Imagine a small group of early Homo sapiens walking across an ancient African plain nearly 200,000 years ago. Suddenly, someone notices movement hidden within the tall grass. A leopard. There is no time for discussion. No carefully formed sentence. Instead, a sharp cry bursts from the hunter's mouth. Instantly everyone understands. Run. Hide. Danger. One sound, one shared meaning, may have saved an entire family. Warning calls may have been among humanity's earliest vocal signals. Even today, many animals use alarm calls that immediately change the behavior of others. Meerkats produce different sounds depending on whether danger approaches from the sky or the ground. Monkeys warn one another about snakes, eagles, or leopards using distinct calls. Birds often react within fractions of a second after hearing an alarm. Early humans almost certainly relied upon similar vocal warnings. Over thousands of generations, those simple sounds may gradually have become more varied, more precise, and more meaningful. Another powerful voice may have shaped language from the very beginning. A mother's voice. Long before children understand words, they recognize familiar voices. Modern research shows that newborn babies respond to sounds they heard before birth. The gentle rhythm of a mother's voice calms fear, comforts distress, strengthens emotional bonds. These ancient connections almost certainly existed long before language itself. Perhaps some of humanity's earliest meaningful sounds were not commands, but expressions of care. The relationship between mothers and infants may have quietly influenced the evolution of increasingly complex vocal communication. Babies themselves also played an important role. Human infants cry more frequently and remain dependent much longer than the young of most other animals. Every cry communicates important information. Hunger, pain, loneliness, fatigue. Parents gradually learn to recognize these differences. The exchange becomes a conversation. Long before words exist. Some evolutionary researchers suggest that this extended period of childhood encouraged increasingly sophisticated communication between parents and children. As human childhood became longer, language may have grown alongside it. Not every early sound expressed fear or need. Some expressed joy. Laughter is one of humanity's oldest forms of communication. Scientists have observed laughter-like vocalizations not only in humans, but also in chimpanzees, bonobos, gorillas, and even rats during play. Laughter strengthens friendships, reduces tension, encourages trust. Long before spoken jokes existed, our ancestors were probably laughing together around evening fires. Those shared moments help build stronger communities, and stronger communities often survive longer. Music may have emerged just as early. No one knows exactly when the first person began singing. Yet singing requires only the human voice. No instrument is necessary. Many anthropologists believe rhythm and melody may have existed before fully developed language. Parents naturally sing to infants. Groups often sing together during work or celebration. Music synchronizes movement, creates emotional unity, and strengthens memory. Bone flutes discovered in Europe demonstrate that musical traditions stretch back at least 40,000 years. Singing itself may be far older. Perhaps before humans could tell long stories, they could already sing together beneath the stars. Emotional sounds likely formed another important foundation: a gasp of surprise, a scream of terror, a sigh of relief, a cry of grief, a joyful shout after a successful hunt. These sounds require no translation. People across every modern culture recognize many of them almost instantly. Emotion may have been one of humanity's earliest universal languages. Hunting also demanded communication. Imagine several hunters surrounding a large antelope. Every movement must remain coordinated. A quiet whistle, a short click, a brief call. Simple vocal signals could direct movement without frightening nearby prey. Combined with gestures, these hunting calls may have gradually become more organized over countless generations. Rhythm may have connected all of these forms of communication. Walking together, paddling together, preparing hides, grinding plants, lifting heavy objects. Humans naturally fall into shared rhythms during cooperative work. Modern psychology shows that synchronized movement strengthens trust between people. Some researchers believe rhythm may have prepared the human brain for increasingly structured speech. Although fascinating, these ideas remain difficult to prove. For centuries, scholars proposed various explanations for how language first appeared. Many of these became famous historical theories. One is known as the bow wow theory. According to this idea, the earliest words developed by imitating sounds from nature. People copied the barking of dogs, the songs of birds, or the calls of other animals. Another proposal became known as the poo-poo theory. It suggested that language grew from emotional cries such as pain, surprise, laughter, or joy. Simple emotional sounds gradually evolved into meaningful speech. A third idea, the ding-dong theory, proposed that sounds naturally reflected the qualities of objects in the world. According to this view, people instinctively matched certain sounds with certain experiences. Finally came the yo-he-ho theory. This theory suggested that language developed from rhythmic chants used during cooperative labor. Groups pulling heavy logs, lifting stones, or rowing together may have synchronized their efforts using repeated vocal sounds that slowly became more complex. Today, these theories remain historically important because they represent some of the earliest scientific attempts to explain language origins. However, modern linguists do not regard any of them as proven explanations. Language almost certainly evolved through a far more complicated process involving biology, brain development, social cooperation, learning, memory, and countless generations of gradual change. No single theory fully explains one of humanity's greatest mysteries. That uncertainty remains part of the scientific journey. Researchers continue comparing archaeology, genetics, neuroscience, linguistics, and anthropology in search of better answers. Each discovery reveals another small piece of the puzzle. Yet the complete picture still lies beyond our reach. Perhaps language did not begin with a perfect word. Perhaps there was no single inventor, no first conversation, no magical moment when silence suddenly became speech. Instead, countless generations slowly added new sounds, new meanings, new connections, until simple calls became shared ideas, and shared ideas became language. And perhaps, language began, not with a sentence, but with a single shared sound. Long before people told long stories, long before language carried history across generations, long before conversations lasted for hours around glowing fires, human speech may have been astonishingly simple. Imagine trying to survive without grammar. No complete sentences, no past tense, no future tense, no words like because, before, after, or tomorrow. No ability to explain a complicated idea. Only a handful of meaningful sounds, combined with gestures, facial expressions, and shared experience. Many scientists believe that language may have passed through such a stage often called proto-language. The idea does not describe a single language spoken by everyone. Instead, it describes a possible step in the long evolution from simple communication to the rich languages we speak today. One of the best-known supporters of this idea is linguist Derek Bickerton. During the late 20th century, Bickerton proposed that before fully developed language existed, early humans may have communicated using isolated words without the complex grammar found in modern speech. According to his hypothesis, people may have spoken using simple labels for objects, actions, or emotions. A hunter might simply say, leopard, Everyone nearby would immediately understand. Danger. Run. Stay alert. No complete sentence would be necessary. Another person might say, water. The group would know it was time to drink or move toward a river. A parent might simply call, child, or perhaps, come. These single words could carry enormous meaning because everyone shared the same situation. Context did much of the work that grammar performs today. Imagine standing beside a river with your family. One person points downstream and says only, fish. Another nods. A third begins preparing a spear. Very little has been spoken. Yet everyone understands what should happen next. This is one possible example of proto-language. Simple words, supported by gestures, shared experience, and observation. Gestures almost certainly remained essential. A pointed finger could identify a distant animal. An open hand could invite someone closer. A raised arm could signal everyone to stop. A facial expression could communicate fear faster than any sentence. The voice and the body worked together. Neither carried the entire message alone. Modern humans still communicate this way every day. We naturally point while speaking. We smile when greeting friends. We raise our eyebrows when surprised. Even in today's languages, body language continues adding meaning beyond words themselves. For our ancestors, it may have been even more important. One of the defining features of proto-language is the absence of grammar. Grammar is the invisible system that organizes words into meaningful relationships. It tells us who performed an action, when it happened, and how different ideas connect together. Consider the simple sentence. The hunter chased the deer. By changing only a few words, we can create entirely different meanings. The deer chased the hunter. The hunter will chase the deer. The hunter chased the deer yesterday. The hunter is chasing the deer now. Modern grammar allows these distinctions almost effortlessly. Without grammar, such ideas become far more difficult to express. Early communication may have depended heavily upon the immediate environment. People likely talked mostly about what they could see, what they could hear, what they needed at that moment. The distant past, the uncertain future, or complicated hypothetical ideas may have remained much harder to communicate. Long conversations were probably impossible. Imagine trying to describe an entire hunting strategy using only isolated words. River, morning, many animals, weight, spear. Much of the intended meaning would rely upon pointing, demonstration, and shared understanding. Over countless generations, those simple combinations may gradually have become more organized. Perhaps 2 words became 3. 3 became 4. Word order slowly gained importance. Certain sounds began indicating actions. Others identified people. Still others described time. No single invention transformed proto-language into modern language overnight. Instead, complexity likely accumulated little by little. Generation after generation. Child after child. Conversation after conversation. To understand this process, it helps to distinguish 3 important ideas. A word is a single unit carrying meaning. For example, fire, water, food. Each word identifies one idea. A sentence combines multiple words according to rules. The fire is burning brightly. The children found fresh water. Sentences allow relationships between ideas to become clear. A language is something even greater. It includes thousands of words, complex grammar, shared pronunciation, cultural traditions, storytelling, memory, humor, poetry, and the ability to create entirely new ideas. Language is not merely vocabulary. It is an entire system for sharing thought. According to Bickerton's proto-language hypothesis, humanity may have spent a very long time somewhere between isolated words and fully developed language. This idea remains influential, but it is not universally accepted. Some linguists argue that language may have evolved differently. Others believe grammar and vocabulary developed together rather than in separate stages. Still others suggest that no clear proto-language stage ever existed. The archaeological record offers very few direct clues. After all, words leave no fossils. Scientists must combine evidence from neuroscience, genetics, anthropology, child development, and comparative linguistics to build possible explanations. Each discipline contributes another piece of the puzzle. Yet none can fully recreate conversations that disappeared hundreds of thousands of years ago. Perhaps the first people never realized they were creating something extraordinary. One new sound, one new gesture, one new shared meaning, repeated countless times across countless generations. Slowly, communication became richer. Ideas became larger. Memories lasted longer. Plans stretched farther into the future. Communities grew stronger. And the human mind discovered increasingly powerful ways to connect with other minds. No single moment transformed silence into speech. No single generation invented language. Instead, language may have emerged through millions of ordinary conversations, each one adding another small step toward the extraordinary complexity we know today. And perhaps, thoughts were becoming larger than sounds. Long before books preserved knowledge. Long before teachers stood before classrooms. Long before history was written upon stone or paper. The greatest library in the world may have existed around a simple fire. As darkness settled across the prehistoric landscape, the dangers of the day slowly disappeared into the shadows. Predators became harder to see. The cold air crept across the grasslands. The stars emerged one by one above the silent earth. And gradually, small groups of early humans gathered around glowing flames. Fire had already transformed survival. It provided warmth during freezing nights. It frightened away dangerous animals. It cooked food, making many plants and meats easier to digest. Its light extended the day long after the sun had disappeared. But perhaps its greatest gift was something far less visible. It created time. For the first time in human history, people could remain awake together after sunset. Instead of immediately sleeping when darkness arrived, they could talk, listen, observe, remember. No one knows exactly what those earliest conversations sounded like. No recording survives. No written words remain. Yet anthropologists believe that the campfire may have become one of humanity's greatest classrooms. Imagine a child sitting beside an elder after a successful hunt. The elder points toward the darkness beyond the firelight. He demonstrates how a lion stalks its prey. He imitates the movement of an antelope. He explains where water can still be found during the dry season. Perhaps only a few words are spoken. Perhaps many gestures fill the spaces between them. The child watches carefully. Knowledge passes from one generation to the next. Without writing, memory becomes everything. Hunter-gatherer communities depended upon experience. Young people had to learn which plants were safe to eat, which berries were poisonous, where dangerous predators often rested, how animal tracks changed after rainfall. When migrating herds usually returned, mistakes could be deadly. Stories offered one of the safest ways to preserve that knowledge. Rather than memorizing long lists of facts, children remembered memorable events. The place where the leopard attacked. The river that disappeared during the Great Drought. The valley where the mammoths gathered every winter. Stories transformed survival into memory. Modern psychology suggests that human beings remember information far more effectively when it is presented as a story rather than as isolated facts. Narratives organize knowledge. They create emotion. They help experiences remain vivid for years, sometimes for an entire lifetime. Many researchers believe this remarkable feature of memory may have benefited prehistoric humans as well. Of course, we cannot prove that early Homo sapiens told stories exactly as we do today. No storyteller from 200,000 years ago left behind a written script. The archaeological record remains silent. What scientists possess instead are comparisons. Anthropologists studying hunter-gatherer societies around the world have found that storytelling often plays a central role in preserving culture. Important lessons are remembered through stories. Children learn social rules through stories. History survives through stories. Ethnographers documenting indigenous cultures across Africa, Australia, Asia, and the Americas have repeatedly observed oral traditions serving as powerful systems for preserving knowledge across countless generations. These observations do not prove that prehistoric humans behaved in exactly the same way. Modern hunter-gatherer societies are not unchanged windows into the distant past. Each possesses its own rich history and unique traditions. Yet these comparisons suggest possibilities that archaeologists continue exploring. Another important element of oral tradition is repetition. Stories survive because they are told again, and again, and again. Every generation becomes both a student and a teacher. Without repetition, knowledge disappears. Memory fades. The chain connecting the past to the future is broken. Long before libraries existed, human minds became living libraries. Songs may have strengthened this process even further. Music has an extraordinary relationship with memory. Even today, many people can remember songs learned during childhood decades later. Rhythm organizes information. Melody makes ideas easier to recall. Anthropologists believe songs may have helped early communities preserve important knowledge long before writing appeared. Perhaps hunting routes were remembered through repeated chants. Perhaps children learned family traditions through simple melodies. Perhaps celebrations ended with familiar songs passed from one generation to another. No one can know for certain. But the possibility is supported by what we understand about memory and music today. The fire also strengthened cooperation. As families gathered together each evening, relationships deepened. Disagreements could be resolved peacefully. Plans for future hunts discussed. Food shared among the group. Young children played safely beneath the watchful eyes of many adults. Elders remained respected because they carried decades of valuable experience. Modern psychology shows that spending time together in shared activities increases trust between individuals. Conversation, laughter, shared meals, music, and storytelling all strengthen social bonds. Communities united by trust often cooperate more effectively during times of danger. For early humans, stronger cooperation often meant greater chances of survival. Anthropologists believe these nightly gatherings may have helped shape the remarkable social abilities that distinguish our species today. Yet once again, we must distinguish evidence from interpretation. Archaeology can uncover ancient hearths where fires burned repeatedly. It can reveal camps occupied across many seasons. It can recover burned animal bones, stone tools, charcoal, and traces of repeated human activity. These discoveries tell us that people gathered around fire. They do not tell us exactly what was said. They cannot preserve laughter. They cannot preserve songs. They cannot preserve stories whispered beneath ancient stars. Those voices disappeared long ago. Our understanding comes from combining archaeology with anthropology, psychology, ethnography, and the study of living human behavior. Together, these fields allow researchers to build careful, evidence-based interpretations while recognizing that uncertainty remains. Perhaps the greatest achievement of those ancient fires was not warmth alone. Around dancing flames, children learned, hunters remembered, families laughed, communities planned, knowledge survived. Generation after generation, ideas traveled farther than any individual ever could. And perhaps, the fire may have illuminated more than faces. It may have illuminated ideas. Long before cities divided nations. Long before maps marked borders. Long before alphabets preserved words upon clay, stone, or paper. Human language was already changing. It had begun as the shared voice of small communities. But as humanity spread across the earth, that single voice slowly became many. Our story begins in Africa. Today, overwhelming archaeological, genetic, and fossil evidence supports the idea that Homo sapiens first evolved in Africa roughly 300,000 years ago. For tens of thousands of years, human populations lived only on that continent. Then, something remarkable happened. Beginning around 70,000 years ago, small groups of people gradually began leaving Africa. Not as one great migration, but through many slow journeys spread across thousands of years. Some traveled along coastlines. Others crossed deserts. Many followed rivers and animal herds into unfamiliar lands. Generation after generation, they moved farther from their ancestral home. Eventually, humans reached the Middle East, then Europe, Asia, Australia, and much later, the Americas. Each migration carried more than people. It carried language. At first, these traveling groups probably remained connected to neighboring communities. But as distances grew, communication became increasingly difficult. Mountains separated valleys. Deserts divided populations. Dense forests isolated villages. Oceans created barriers impossible to cross for countless generations. Groups that once shared the same way of speaking gradually lost regular contact with one another. And language began to change. This process continues even today. Think about how accents differ between regions of the same country. People may understand one another, yet pronounce words differently, use different expressions, prefer different vocabulary. These regional differences are called dialects. Given enough time, dialects can slowly become entirely separate languages. No single moment announces the change. No one wakes up one morning speaking a completely new language. Instead, tiny differences accumulate over generations. A pronunciation shifts. A word disappears. A new expression becomes popular. Children learn the slightly altered version. Their children change it again. Centuries pass. Then millennia. Eventually, people who once spoke the same language may no longer understand one another at all. This gradual transformation is one of the most remarkable features of human language. Unlike stone, language is never still. It is always evolving. Linguists often compare language to a living tree. Every language has ancestors. Some branches divide into smaller branches. Others disappear entirely. Some continue growing for thousands of years. These relationships create what scholars call language families. A language family is a group of languages that evolved from a shared ancestral language. Perhaps the best-known example is the Indo-European language family. Today, this enormous family includes English, Spanish, French, German, Russian, Persian, Hindi, and many others spoken by billions of people around the world. Although these languages sound very different today, linguists have discovered remarkable similarities in grammar, vocabulary, and pronunciation. By comparing thousands of words across many languages, researchers concluded that they likely descended from a much older language. This ancient ancestor is known as Proto-Indo-European. No written record of Proto-Indo-European has ever been discovered. No ancient manuscript survives. Instead, linguists reconstructed parts of it by carefully comparing later languages. It is one of the greatest achievements in historical linguistics. Yet Proto-Indo-European was not humanity's first language. It appeared relatively recently, perhaps 6,000 to 7,000 years ago. By that time, humans had already been speaking for tens of thousands of years. Countless earlier languages had already appeared, changed, and vanished forever. Many left behind no trace at all. This reminds us of an important distinction. Language and writing are not the same thing. Today we often associate language with books, letters, text messages, newspapers, but writing is actually a very recent invention. The earliest known writing systems appeared only about 5,000 years ago. Before that, human beings had already been speaking for perhaps 100,000 years, or even longer. Entire civilizations lived without writing. Stories survived through memory. Knowledge passed through conversation. History traveled from one generation to the next by voice alone. For most of human existence, language existed without a single written word. Writing did not create language. Writing simply gave language a permanent home. Without writing, languages continued changing naturally. New words appeared. Old words disappeared. Pronunciations shifted. Grammar evolved. Sometimes neighboring communities influenced one another through trade and migration. Sometimes isolated groups developed entirely unique ways of speaking. Every human journey left its mark upon language. Even today, new words enter our vocabulary every year. Technology creates new expressions. Cultures exchange ideas. Young generations reshape pronunciation. Language never stops evolving. It remains one of humanity's most dynamic creations. Scientists continue studying ancient DNA, archaeology, linguistics, and migration patterns to better understand how languages spread across the world. Each discovery helps reveal another chapter of humanity's extraordinary story. Yet many mysteries remain. Thousands of ancient languages disappeared before anyone invented writing. Their sounds, their songs, their stories, their names are lost forever. Only echoes remain within the languages spoken today. From one small population in Africa, humanity spread across every continent except Antarctica. With every migration, every generation, and every new homeland, language quietly transformed alongside us. The voice of one community became the voices of many. Dialects became languages. Languages became families. Families became the extraordinary diversity we hear across the modern world. And slowly, almost without anyone noticing, One voice had become thousands. Long before cities filled the earth. Long before books preserved knowledge. Long before history was written. Humanity had already discovered something extraordinary. The ability to share thought. Our journey has carried us back hundreds of thousands of years. To a time before alphabets. Before kingdoms. Before civilization itself. We have followed the long and uncertain path that may have transformed simple communication into one of humanity's greatest achievements. It began not with writing, but with survival. Early humans relied upon gestures. A raised hand. A pointed finger. A glance toward hidden danger. Long before complete language existed, the body itself became a powerful tool for communication. These silent signals allowed small communities to hunt together, protect one another, and survive in a world filled with uncertainty. Over countless generations, something remarkable began changing inside the human mind. The brain became increasingly capable of symbolic thought. Objects no longer represented only themselves. A sound could represent an animal. A gesture could represent danger. A memory could become a story. Ideas that existed only inside one person's mind could slowly begin traveling into another. That transformation changed everything. We explored how the evolution of the brain may have made language possible. Specialized regions such as Broca's area and Wernicke's area helped shape the extraordinary ability to produce and understand speech. Memory became stronger. Planning became more sophisticated. Cooperation expanded beyond immediate survival. Yet, as science reminds us, brain size alone did not create language. Rather, language appears to have emerged from the remarkable interaction of biology, social life, learning, and millions of years of gradual evolution. We also met one of our closest human relatives, the Neanderthals. For generations they were misunderstood. Today, discoveries such as the Kebara hyoid bone, the FOXP2 gene, and studies of hearing and vocal anatomy suggest they may have possessed far greater communication abilities than scientists once imagined. Did they speak with language as rich as our own? Did they use a simpler system? Or something entirely different? For now, the evidence cannot provide a final answer. The silence of Neanderthals continues to challenge our imagination. We then explored one possible stage in language's evolution, proto-language. Perhaps the earliest conversations consisted of isolated words, supported by gestures, facial expressions, and shared experience. No grammar, no long conversations, only simple sounds carrying powerful meaning. Over thousands of generations, those sounds may have slowly grown into increasingly complex language. Whether this process unfolded exactly as some scientists propose remains uncertain. But it reminds us that great changes often begin with very small steps. Around ancient campfires, another transformation may have taken place. Stories, songs, shared memories, children learning from elders, knowledge passing from one generation to the next without writing. Anthropology, psychology, and ethnography suggest that storytelling may have strengthened memory, cooperation, and social bonds. Although archaeology cannot preserve ancient voices, it preserves the hearts where those voices were once heard. Finally, we followed humanity beyond Africa. Small groups spread across deserts, forests, mountains, and distant coastlines. Separated by geography and time, their languages slowly changed. Dialects became new languages. New languages formed entire families. Today, thousands of languages are spoken across the world. Each one carries the echoes of countless generations who slowly shaped the sounds we speak today. After all we have explored, what does science actually know? The evidence strongly suggests that language did not appear overnight. Instead, it evolved gradually through countless generations of biological and cultural change. We also know that language transformed human civilization. It allowed knowledge to accumulate rather than disappear. Ideas could travel farther than individuals. Communities became larger. Cooperation became more sophisticated. Culture flourished. And nearly all researchers agree that spoken language almost certainly existed for tens of thousands of years before the invention of writing. Writing did not create language. It simply allowed language to leave permanent traces behind. Yet some of the greatest mysteries remain unanswered. No archaeologist has discovered humanity's first word. No fossil preserves the first complete sentence. No evidence reveals the identity of the first person who truly spoke. And no recording survives to tell us exactly what those ancient voices sounded like. Perhaps those answers have been lost forever. Or perhaps future discoveries will uncover clues we cannot yet imagine. That uncertainty is not a failure of science. It is a reminder of how extraordinary our journey has been. Every new fossil, every archaeological discovery, every genetic breakthrough adds another piece to a puzzle still waiting to be completed. The search continues. And perhaps that search is one of humanity's greatest strengths. Long before history was written, before civilizations rose, before the first word was carved into stone, our ancestors were already reaching toward one another, not only with their hands, but with their voices. Exactly what those first sounds were, we may never know. But somewhere in the distant past, a simple sound became a shared idea. A shared idea became language, and language changed humanity forever.